Welcome back to Stylize Station. I wanted to tell you all something that I'm really excited about. I just launched our membership, and the whole idea is to make learning art way more accessible. Instead of buying individual courses, you get access to all of our courses for the price of one. We created this membership for people who wanted to dive into tons of our content, but couldn't afford to grab multiple courses. And to help you out even more, we are starting an early bird special right now. The first 100 people get locked in at the lowest price it'll ever be. I'll be adding my own mini lessons starting in a few weeks. We've got a massive Unreal Engine 5 environment art course on the way for the membership, and there's so much more in the pipeline. Get in now while it's at the lowest price, and I'll leave a link in the description. Okay, let's get into the video.
Hey Stylize Station, my name is Kai, I'm a technical artist, and today I want to show you how I created this procedural house generator with Houdini and Unreal Engine. So let me show you how it works. All you need to do is to drop a Houdini asset on the scene and wait while Houdini does its magic. After a while, you get a finished house. If you want to change something about the house, for instance height, you can easily do so by adjusting the settings. The same principle applies to width or any other setting you created, but I won't explain all of them in this video. The idea to make a procedural asset like that came to me when I was playing a game called The Finals by Embark Studios. Embark are known for heavy use of Houdini in the development process, and honestly I was really inspired by that procedural workflow. It's extremely flexible and allows a small group of people to create a huge amount of content in a relatively short amount of time. Also, since I'm a more technical person, the idea of writing code to create art feels natural and more appealing to me. So I decided to try Houdini for myself and see what I can do with it. About the game, I noticed that many houses have the same composition and structure. The only difference was the size of the house itself. So basically, the size of the house was the only driver for everything else. The number of floors, windows, roof, and so on. Because of that, the idea of a house generator felt quite reasonable and I decided to stick with it. Before I started working on the house, I needed to collect as many references from the game as I could to have a clear picture of the desired result. Otherwise, it would have been really difficult to decide what to include in my project, and I would have spent much more time working on it. As you can see, I have a lot of pictures here, ranging from in-game screenshots of individual props to screenshots of other people's finished projects I found on ArtStation. The process of collecting in-game references was quite simple. I just loaded the tutorial map and screenshotted everything I wanted to include in my project. Try to pay attention to small details. It will be very useful once you start modeling. Before I show you how I approached the blockout process, I want to quickly introduce you to Houdini and explain why it is so powerful and how it is different from other 3D software. So, what is Houdini? It's just another 3D program like Blender or Maya, but with one huge difference. In Houdini, everything is procedural and every action is represented by a node. Let's compare Houdini to Blender and the difference will become very clear. Here I am in Blender. Let's do something basic like create a cube, extrude the top face, and then bevel this edge. Quite simple, right? Let's try to do the same in Houdini. As you can see, in Houdini every action is represented by a node. Nodes have parameters, and the result of one node can be passed to another one, which allows you to create any logic you want. If you have some experience with Substance Designer, this will be very familiar to you. What's so powerful about this, you might ask? Well, let's say I want to change the initial size of the cube, but keep everything else the same. In Blender, there is really no easy way to do this. Yeah, I can change the scale of the cube, but the beveled edge will be scaled as well, which is not exactly what I want. In Houdini, on the other hand, you can just change the parameters of the first node and everything else will adapt to the new size of the cube. Pretty cool, right? That's just scratching the surface. You can create extremely complex logic and still reliably change anything at any step without breaking the whole thing. This is called non-destructive workflow and Houdini is really good at it. I won't go deeper into details though. Houdini is quite complex and explaining every concept will take a long time. If you want to take a look at Houdini yourself, I will provide some recommendations on how to learn it later in the video. Let's come back to the house. As I mentioned before, the house is driven only by its size, so in a really simplified way, a house is a box. Here I removed all the generation logic, and indeed, the only thing that's left is just a box. That's a good starting point for our blockout. Let's add some details. Usually, a house has a roof, and here's the basic version of the roof without any props. The approach was quite simple. I just extruded the top face of the box, added thickness and some details like side faces and the base of the roof. It looks okay for now, but we will return to this later. We also need some windows. For that, I selected only the front walls and divided each wall into a grid. The amount of grid cells depends on the size of the wall and adjusts dynamically. Now we can iterate over each individual cell and create a hole for the window using a Boolean operation. The geometry that cuts out the window is a simple rectangle. I just added some thickness to it and copied it to the position of the future window. Notice that sometimes windows can be rounded. For that I have a different shape, but the logic is the same. Just add thickness and copy it to the points. But what about the doors? Cutting out the doors works almost the same as cutting out the windows, but instead of iterating over each cell, I randomly select one cell on the first floor and mark it as a door. Then it's the same process. Add some thickness to the cutout shape and use the Boolean operation. When I have holes for windows and doors, I simply merge them into one thing and add some thickness to it. It works well enough for a blockout, so let's move on. The last thing we need to add to the house is the foundation. For that, I simply extruded the bottom face of the box, added some thickness and cut out holes for the ventilation. Let's see all of this combined together. And don't forget, I can change the size of the box and the system will adapt to it. That's why procedural generation is so powerful. When the base shape is finished, we can start adding details. I will not go too deep into how I made everything. Explaining all of this will probably take more than an hour and it's definitely out of the scope of this video. Let's talk about the roof. Here's how it looks with all the details. I have added roof tiles, some roof props and rain pipes. Let's take a look at them. Starting with the roof tiles. First, I modeled individual tiles in Blender. There are two variations. One tile acts as a default tile that lies on the flat part of the roof, and the other one acts as a tile that covers the top edge of the roof. Then I uploaded models into Houdini and made two subgraphs with them. One spawns only the top tiles and the other one spawns only the default ones. Spawning top tiles is quite simple. We just need to get the top edge, resample it to get some points, and copy the tiles to these points. Some tiles might go beyond the boundaries of the roof, so I use a Boolean operation to cut the protruding parts. Also, notice that I use a loop instead of just copy to points node. I do this to randomize rotation and vertex colors for each individual tile. Vertex colors will be used in the material, but we'll talk about this later. The logic for spawning default tiles is quite complex, but in a nutshell, there are two steps: creating a tile canvas and placing the canvas on the flat parts of the roof. A tile canvas is basically a huge grid of tiles with random orientation and vertex colors. The area of the canvas should always be bigger than the area of a roof side. Gladly, the code handles that. After I get a tile canvas, I orient it along the roof side and cut the parts that go beyond the roof. And that's how roof tiles are made. I could use a simple texture though, but the approach with the real geometry seemed more interesting and better looking to me. About roof props. Same as with the tiles, I first modeled all the props in Blender. I have 3 types of antennas and 1 type of a pipe. Then I loaded all the props in Houdini and scattered them around the roof. I made sure they were distant enough from each other so the models wouldn't intersect. Nothing very interesting about it. The last thing we need to cover for the roof is rain pipes. Making them was tricky. We can't just model them because the height of the building could be changed and the rain pipes should adapt to it. Instead, I decided to make them fully procedural. Gladly, the geometry is quite simple and Houdini has a lot of tools for procedural modeling. I divided them into 2 parts: the top part that collects water and the pipe itself that goes from the top all the way down. The top part is made by detecting the edge of the roof, sweeping and beveling it, and then adding some details. For the pipe itself, I had to create a custom node that makes an edge that doesn't intersect with the roof. Then I just swept the edge, added some supports, and a curved cap at the end. Moving on to the body of the building. Since most of the attention of the viewer will be directed to this part, we need to pay special care to small details, otherwise the building will not look convincing. The first and the most obvious thing we need to add is windows, and not just a frame and glass. If we take a look at our references, we can see that windows might have additional details like shutters, plants, or even balconies. These details will add coziness and convince the viewer that someone lives in the building. Let's start with the base window. As with other props, I modeled it in Blender. I also made sure it has the same size as the mesh I used for Boolean operation in Houdini. It will help to seamlessly fit windows into the holes. I have three models, a glass, an inner and an outer frame. Then in Houdini I just merged them into one thing and copied it to Windows points. Since the size of the mesh is the same as the size of the hole, it fits perfectly. It's time to add some additional details. For that I modeled shutters, a plant pot and a balcony. In Houdini I just randomly add them to the base window. Each window gets a unique random seed, hence a unique set of modules. So even despite the small number of modules, in the end we get a large number of window variations and they almost don't repeat each other. Don't forget, the building has two types of windows, a squared and a rounded one. For rounded windows I use absolutely the same logic with slightly different models. Oh, and about the plant pot. It has three variations of a plant that is also selected randomly. Some pots might get this hanging plant, some might get a snake plant, and so on. Plants are also made in Blender. They were supposed to be used in a different project, but I ended up reusing them for the building. The next thing is doors. They are made in a similar way. We have a base version and some additional details. The door itself has an outer frame and two variations of the base mesh that are selected randomly. Additional details are a door awning, a mailbox, and stairs. Stairs are actually made procedurally and adapt to the height of the foundation. I also added these edge decorations and cornices between the floors. The building looks more cohesive with them. Finally, it's starting to look decent, but we're still missing some details. If we take a look at the references, we can see a lot of small props like ground plants, benches, trash bins, and so on. Same as before, I modeled all of them in Blender and added to Houdini. I have ground plants, benches, trash bins, and lamps. I also added some randomness to it. For instance, plants near doors are randomly selected from 4 different types. As you can see, with Houdini it is possible to create really complex logic out of simple blocks. It's quite similar to programming, you just layer the complexity. Small systems are controlled by bigger systems are controlled by even bigger ones, and so on. But in the end, all of this complexity is controlled by very simple parameters that anyone can use. Back to the building. Once all the geometry is ready, it's time to talk about the materials and how to even approach creating materials for procedural assets. A little disclaimer though, I will talk only about the unusual techniques I used in my process. I won't talk about standard practices like baking maps or creating textures in Substance Painter. Let's start with the most important material, a wall material. It takes most of the screen, so it needs to be really appealing to catch the attention of the viewer and give the building a cozy and warm feeling. My main inspiration for materials and colors was this work I found on ArtStation. I really love cozy and inviting look of the buildings, the variety of plants, and simple but really good looking materials, especially this nice yellow plaster. My wall material has 2 layers, bricks and plaster. I also can control the blending of the layers, for instance, how visible the bricks are, their location, or even the contrast between plaster and bricks. Let's talk about how this material is done. First, I made each individual layer in Substance Designer. Here are the bricks, and here's the plaster. Then in Unreal Engine I have this master material that blends 2 materials using a Blend Material Attributes node. An alpha for this node is generated by a Height Lerp node. Height Lerp works similar to a Lerp node, but adds more details, since the blending is controlled by an additional height texture. In this case, I use the height from the bricks. Also, there is a parameter called a transition phase. It's just a mask that controls which layer will be visible at a certain point. I use a gradient noise as this mask, since it provides interesting results and can be controlled easily. But what about UVs, you might ask? Since the size of the building is procedural, I didn't want to rely on UVs. Yeah, I technically could generate them in Houdini, but making the logic would take a lot of time, and I decided to go with a simpler approach, a tree-planar mapping. Even though it's somewhat expensive on the GPU, it works really well for assets where you can't rely on UVs, and also you can easily control the scale of your textures with it. That's it for the wall material. Let's talk about the roof tiles material and how vertex colors are used in it. Same as with the wall material, I started with the material in Substance Designer. It looks like this. I have added some color variation, dirt and scratches. In Unreal Engine, I again use a triplanar mapping to seamlessly blend details between individual tiles across the whole roof. But what about the vertex colors? Remember how I generated a random color per tile in Houdini? I used this to make each individual tile look slightly different by multiplying the vertex color with the color we got from the texture. It's actually better to show it. Let's disable this feature. Notice how boring the roof looks when I stop using the vertex colors. All the tiles look almost identical. Let's make it 2 times stronger than usual, so you could see it better. Now some of the tiles are brighter and some are darker. That adds some variety to the look of the roof with very little performance footprint on the GPU. By the way, I applied the same principle for leaves of the plants, but instead of just multiplying base color by vertex color, I use vertex color to drive the hue offset. The effect is really subtle, but still it adds some variety to the look of the plant. To add even more details to the building, I use one cool trick. I spawn procedural dirt decals between the floors. Spawning them with Houdini is done by simply creating a set of points with correct orient, scale, and material attributes. When Houdini engine processes these points, it generates them as decal actors with correct transforms and materials. The decal material itself samples the texture with a custom tiling UV. I can control the tile length as well as the tile offset. The tile offset is also driven by the vertical position of the decal actor, so dirt would look different on the different floors. The rest of the materials are made using standard techniques. If it's a surface material, for instance a concrete or a metallic pipe, I first make the material inside Substance Designer and then use triplanar mapping to apply it to the meshes I need. If it's a prop material, I simply bake some maps and paint the prop in Substance Painter. Really nothing unusual here. Oh, and one more thing. How do I apply materials from Unreal Engine inside Houdini? It is done by using an Unreal Material node. This node simply adds an attribute that contains a path to the material. When Houdini Engine is generating the geometry, it reads that path and automatically assigns the material you provided. You can also do some cool tricks with it. For instance, you can assign random material variations for the same mesh. In my case, I do this for window shutters. Some of them are green and some are blue, but the mesh is the same. I also want to mention how I approached lighting and rendering of the scene. Honestly, I didn't do anything special. I just used the standard lighting setup with default actors, such as directional light, sky atmosphere, and so on. There is one thing I changed though. For my skylight, I changed the source type from captured scene to specified cube map. I used this cube map texture and it gave more interesting results compared to the captured scene mode. For rendering, I used an official plugin called Movie Render Q. It's an amazing tool if you want a high quality renders of your scene, but again, nothing really special here. And that's it. Thank you so much for watching this breakdown. I hope you got something interesting out of it. As promised, I want to give you some advice about how to approach learning Houdini, in case some of you want to dive deeper into it. First of all, please remember that Houdini is an extremely complex program, so feeling overwhelmed is normal. Just give it some time and be patient. With practice, it will start to get easier, and after some time you will be able to create truly amazing things with it. If you are an absolute beginner, I recommend you to start with the official tutorials. Even though they are quite basic, they will give you a good foundational knowledge about core principles and workflows in Houdini. After the basics, you can start to dive deeper into your topics of interest. When I was preparing for this project, I decided to learn more about VEX, Houdini digital assets, and procedural modeling techniques. But again, with Houdini you can do so many different things, so feel free to choose any tutorial that seems interesting to you. Also, I would recommend the Indie Pixel YouTube channel. This guy has a lot of easy and useful Houdini tutorials that are very good for practicing and honing your skills. And if you want to dive even deeper and create your own variation of a building generator, then I can't recommend enough to take a Procedural Lake Houses course by Anastasia Opara. Even though it might be a little expensive, it will give you an insane amount of knowledge and cool tricks when it comes to procedural house generation. Thank you again, and until next time, bye!